This is MATD 1534, and this morning we're going to look at the domain and the range. Now remember, the domain is all about our x coordinates, and the range is all about our y coordinates. So basically, when I look at the domain, I ask myself, will this be possible for me to enter all negative numbers into the equation, into the function? Will it be possible for me to enter 0 into this equation or the function? Will it be possible for me to enter positive x coordinates into this function? And then I try to see what are the restrictions, what are the ones that's not possible, and then we can find the domain that way. The range is all about the y coordinates. So again, now, when I have the domain, in other words, remember, if we look at that mincer example that we did, if you have a mincer and then you first define what you can throw into the mincer. So you define that you may only throw in meat or so. Once that is done, it means the domain is now in place. Then we can decide what the possible outcomes will be. Like if it's meat, it will be minced meat, and so on. So we first define the domain. Now, if the domain is ready, then I look at what is the possible answers I can have. In other words, can I have negative answers? Can I have zero answer which will be 0? Can I have positive answers? Okay. And then I can define the range. Now, if we look quickly at just the 3 examples here, I mean, if I look at my y is equal to 2, there's absolutely no problem with the x coordinates. X can be negative, here x is negative, here x can be 0, here y can, x can be positive. So x can be absolutely anything. So the domain is anything. X is an element of R or negative infinity to infinity. If I look at the y coordinates, I see y can only be 2 here. It's like walking on level 2 in a building. All the rooms will have a floor number of 2, you see. So y can only be 2. Remember, then we use the curly brackets. If we look at example 2 here, so first of all I look, can I have negative x? Yes, here all x coordinates are negative. And here I've got a dot, so x can be 0. And here I see I can have positive x coordinates. So there's no restriction on my x coordinates. Therefore, the domain again is minus infinity to infinity. Now, if that is in place, in other words, I already have my domain ready now. Let's look at what is the possibilities for the answers for the y coordinates. Well, I can have y here and here and here and here and here, and they're not inclusive. And then there's a gap. There's absolutely no answers here. There's no y coordinates there. So, but then it is 0 again, and it is positive. So in other words, my range will be from negative infinity all the way to this minus 1, coming up from negative infinity, because remember, this line is continuing downwards here. So meaning it comes from negative infinity all the way to negative 1, which is not included. And then there's a gap, which I indicate there with another section, another region. And then it starts at 0, which is inclusive, and then it goes up to infinity. So that is then the range. Okay. All right. This third example, while x can be 0 here, and x can be positive all the way to 3, cannot get past 3, and there's no negative x here. The graph is only drawn from 0 to 3. So from 0 to 3, inclusive both sides. What about the answers now? Well, there's no negative answers here. There's no graph under the x-axis. No negative answers. So it starts at 0 and it goes all the way to 4 there. From 0 to 4. Okay, so that will be the range then. Range is always the answers, the y coordinates. Now, remember we always look at our mother graph. So in general, we can now say in general, if I have a polynomial, just a normal polynomial, there's absolutely no restriction on the domain. Here we just look at the domain for the moment. So it will be minus infinity to infinity. But it's very good if we understand these in general ones, because it helps us if we if we zoom in to specific ones. So if we have a polynomial, that's the parabola, the straight line, the cube function, etc., there's no problem whatsoever on the domain side. Remember, we're only looking now at the domain, not at the range. Okay. Now, if we look at a fraction, a rational function, in other words, hyperbolas types, then we see that when we look at the domain, we cannot divide by 0, like we did with the boundary points and the restrictions, you will remember. So we will find the restrictions here, that is going to be plus and minus 2. So in other words, our number line there will be at minus 2 and at 2, there will be restrictions. Okay, and therefore, this will be true, this will be true, and this will be true. So in other words, it will be from minus infinity to minus 2, from minus 2 to 2, and from 2 to infinity. That will be the domain. That is if I write that now in interval notation. I can also say x can be anything, but x cannot be plus or minus 2. That's if I write it in set builder notation. But remember, for this course, we like you to do it in interval notation, so you will write this part. The absolute value graph, we know that the absolute value graph looks like this. So, in other words, there's no restriction on the x coordinates whatsoever. No restrictions. And therefore, x can be anything. Remember, we're not looking at the range now. Remember, there's a restriction on the range here, but we're just looking at the domain at the moment. And then the very important third equation, the root function, there the inside must always be greater and equal to 0. We cannot, remember, we're working in the real number system here, so x cannot be negative. Therefore, x must be greater and equal to 0, meaning from 0 to infinity. Okay, so let's look at the example here. Find the domain and the range now in this example. Find the domain and the range. Now, number 1 is just a parabola, so we know what it looks like, and therefore we know that if we draw the graph there of the parabola, we know that x can be anything, as we said for polynomials here at the top. We said when it's a polynomial, there is absolutely no problem with the domain. So then x will be anything for the domain, as we indicated here. But remember now, for the range, there's no negative y answers that we can get. Look, as I said, say now you don't know what the graph looks like. Then ask yourselves, can you have negative answers? No, it's impossible, because this is a square. I cannot have negative answers. Whatever I substitute into x, I'll never find a negative answer. So therefore, the negatives are out. So can I have an answer of 0? Yes, because if you give me x is equal to 0, and I substitute it, I have 0 squared, which is 0. So yes, I can have an answer of 0. Can I have positive answers? Yes, all the way, because this is a square. All the answers is going to be positive. So in other words, the range should be 0 to positive infinity, which we have indicated here. Okay, when we look at the cube function, it's a polynomial again. No problem on the domain. Now, can I have negative answers? Yes. If I give you -3 or -4 or -10 or -100 or -1,000 or -1,000,000, I'm going to get negative answers. Yes, I can. Can I get 0? Yes, because if I make it -1, substitute -1 into here, I'm going to get 0. Okay, so yes. Can I get positive? Yes. If I give you 10 or 100 or 1,000,000, whatever, the answers will be positive. So no problem on the range. Therefore, -infinity to infinity. Okay. Now, here we've got a combination now. We have a fraction and we have the surd, meaning we need to combine now the restriction plus the condition for surds. So the condition for surds is that the inside must be greater and equal to 0, giving us x is greater and equal to 1. But the restriction part is that I may not divide by 0. Therefore, we have to remove the equal here, and therefore we will only have x is greater than 1, like I've done here also for you to show you that. So x cannot be 1, therefore the domain will be from 1 to infinity. In other words, x is greater than 1 from 1 to infinity. Now, finding the range here is a bit of a problem now. Okay, but let's try. If you don't really understand, it can be problematic. But let's try. Can I have negative answers here? Well, this is a positive square root, meaning all things here in the denominator is going to be positive, and the top is also positive. So I'm never going to have any negative here. So, okay, I know now I cannot have any negative. All right? Now the question is, can I have 0 for an answer? Well, this is a fraction. And when is a fraction 0? Well, only if the top is 0. Remember, only when I have 0 over something, I'll have 0. Remember, 0 underneath is the restriction. Okay, so no, I can never have 0 here because there's a 1. And because there's a 1, this fraction can never give me an answer of 0. So 0 is out. So now I know I can't have negative answers and I can't have 0. Okay, can I have positive answers? Yes, definitely. We saw it when we did the positive over the positive. So I know I can have positive answers. Okay, so therefore my range is going to be from 0 to infinity, meaning I not included the 0, meaning not included the 0. So in other words, I can have positive answers. I can't have negative answers, and I can't have 0 for an answer, but I can definitely have positive answers. Okay, let's look at the last one here, example, which is the piecewise function that you should be okay in now. If we look at the domain, we see that x is greater and equal to 0 there, and x is less than 0 there, meaning all the x values, because it can be 0, can be positive, can be negative, so absolutely everything, so no problem here. Okay, what about the range? What about my answers? Well, it looks like I can only give you 2 answers, 1 or -1, because y can be 1 or y can be -1. It can be nothing else. So therefore, the range is just going to be 1 and -1. Okay, I hope you understand this first example about doing the domain and the range here.